Hello, everybody. So today we are going to look at the law of sines, the ambiguous case. Let's get this camera set up here. Okay. So the law of sines, the ambiguous case, is a special situation that can occur with these solving triangles problems where there could be two possible triangles that exist as the answers. So here are the stipulations where you know it's this kind of ambiguous case. If it's angle side-side, or side-side angle is given to you, and if the side opposite the known angle is smaller than the adjacent side. So over here, A is opposite of angle A, and it's smaller than the adjacent side B, and it's also angle side-side. So I'm going to go through this problem with you here, and then you guys can try some out. I'm going to show you a couple other just thoughts at the end, but here we go. So triangle ABC has an angle of 32 degrees. If we try to sketch this angle out here, here's my angle A. We have the side of undetermined length. We have an angle of 32 degrees right here. That looks like it's about 32 degrees. And we have C over here, which makes this side B. So side B is going to be 10. Now the reason why this is ambiguous is if we try to draw this side length of 8 over here right now, opposite of A, there's actually two different ways we could draw it. We could draw it going out like this, where 8 would be over here, or we could draw it like this, where the 8 is over there instead. Because there are two possible triangles that could exist from the given information, we are going to solve for both of them. So we'll start off with just the law of sines, which will be sine 32, opposite of 8, is equal to sine of B, the one we don't know, divided by 10. Now, if at any point during this video you want to pause, please do so to get caught up with the notes or to think about anything I've said. Make sure your mode is in degree mode. Mine is here. I'm going to now do 10 sine 32 divided by 8. I get 0.6624. If I do inverse sine, I get an answer of 41.5 degrees. So angle B is 41.5 degrees. Now, if we take a look at the two possible places where B could be, it could be right here, or it could be this one over here. So out of these two choices, this one definitely looks like it could be 41.5. This one's an obtuse one, so that's not going to be the winner. So this angle here is 41.5 degrees. Because this is an isosceles triangle, the purple one I made here, this angle would also be 41.5 degrees. If this one's 41.5, these two angles, being supplementary, they're a linear pair, would add up to 180. So if I do 180 minus my answer, 138.52, that's what angle B will be in the other triangle. So speaking of the other triangle now, down here, what I recommend doing with these problems is setting up two different sets of possible answers. So I have triangle 1 and triangle 2. Triangle 1, my angle B was 41.5 degrees, and triangle 2, my angle B was 138.5 degrees. These ones will always add to be 180 degrees because of that isosceles triangle situation that I talked about earlier. From here, it's going to be a matter of treating these as separate problems and going through the solving process. Let's look at triangle 1 first. In triangle 1, in order to find angle C, I'm just going to do 180 minus those two angles. And I get 106.5 degrees. And then I'm going to use law of sines again. Sine 32 over 8 equals sine of 106.5 over side C. do a little cross multiplication. 8 divided by sine 32. And we get a C value of 14.5, which is what goes here. So that's one possible triangle that could exist there. Now let's take a look at the other possible triangle over here. Same solving process. We get 9.5 degrees, so it's a very small angle. That's talking about like this guy right here, very small, that makes sense. And then if we do the same process, except this time, instead of 106.5 up there, I'm gonna have sine of 9.5. And same general idea, 8 sine 9.5 divided by sine 32, and I get 2.49. And there it is. And this is how the answer should look in the end. You should show both triangles completely solved out whenever you have this ambiguous case. So once again, the ambiguous case happens when the side opposite the known angle, that's 8 over here, is smaller than the adjacent side of 10, and when you have angle side side. I'm going to show you two other possibilities that could occur as kind of stipulations to the law of sines. First off, if the A was bigger than B, so in the previous problem, A was 8, B was 10, now I'm flipping it. This would only have one possible triangle. The only triangle that could exist is this very obtuse looking triangle with a 10 here. If I tried to draw a 10 this way, I wouldn't be able to fit it in this space. It would end up going over here somewhere to make 10, and then the triangle wouldn't exist because 32 wouldn't be part of it. So there's only one possibility when we have a situation like this. Another possible situation is one like down here. There could be no triangle at all if the side is too small. So for example, in this problem here, A is smaller than B. The side opposite the known angle is smaller, but if this is 10 and this is 2, we're not going to be able to get down to this other line. That's impossible to draw that figure. So there's no possible triangle that could exist with those dimensions. And on the calculator, what'll happen here is if you do the math out, you'd get sine 32 over 2 equals sine of B over 10. And if we did 10 sine 32 divided by 2, we end up with a sine ratio above 1. So we know this is not going to work out. We can't have sine ratios above 1. And your calculator will tell you there's an error there, and that's how you kind of know that the side length is too small, because the calculator can't do the function. All right, guys, hope you enjoyed that. And check out the problems and ask me any questions that came up.